Welcome to Maths for All. I'm Aisling Flynn. This is the line 1.6, area of a triangle. Area of a triangle. So we've looked at areas and volumes before, and we learned that the area of a triangle is gotten by multiplying half the base by the perpendicular height. Okay. Looking at this green triangle here on the right, we can count the units, count the length of the base or the bottom, which is 1, 2, 3, 4, 5, 6, 7 units long. And we can look for the perpendicular height to the highest point. So perpendicular means that our height must reach the base and meet it at 90 degrees. And counting the units up, that's 1, 2, 3, 4. Our perpendicular height is 4. So if you have a triangle that has one of its sides horizontal, like so, the picture here, or indeed vertical, you can literally just count the base and a perpendicular height. So half the base by the perpendicular height, that would be half of 7 times 4, which is half of 28, which is 14 square units, and that's our answer. Okay, and we have another triangle here. It's a bit different, but if we measure, we have 1, 2, 3, 4, 5, 6, 7 units again as the base, and the highest point D is a little bit right of the previous one, but the perpendicular height is still 4 units. So that one there will have 14 square units as its area also. Now, this question says, find the area of the triangle with the vertices. Now, a vertex is a corner or a point of a triangle. Okay, 1, 5, minus 3, 1, and 5, 4. So we probably should draw this on a graph. So there's 1, 5, minus 3, 1, and 5, 4. And we'll join the 3 of those up and we make a triangle. Now if you notice here, none of the sides are vertical or horizontal, so we can't simply count the squares, okay, and we wouldn't be able to get the perpendicular height by that method either. Okay, so what do we do? Well, this is a graphical approach, okay, and let's go through it together. Okay, so first I've drawn a rectangle all around that triangle so that the 3 points hit one of the sides, and I've started with the corner of a rectangle on one of the corners of the triangle. Okay, so to take it all in. So we know how to get the area of a rectangle. Okay, that's the length by the width, or length by the height. And if you count the boxes, you'll see that the blue rectangle is 8 squares across, 8 units, and 4 units up. So 8 fours is 32. So the area of the big blue rectangle there is 32. Now, so what we're going to do next is we're going to look at these nice triangles outside of our red triangle, and they're easy to calculate because we've got horizontals and verticals, okay, and perpendicular heights, and we're going to calculate each of their areas, and we're going to take them away from the blue triangle, and what we'll be left with then is inside the red triangle the answer we want. Okay, so let's do it bit by bit. So we've a green rectangle here, and do the counting of the units or the boxes, and it has base, whichever side you choose to be your base, 4, and perpendicular height 4. So half of 4 times 4 is half of 16 is 8, so that has area 8. Okay, we'll repeat that now for the red triangle over here. If you count your units again, it has a base of 4 and a height of 1. So its area is half of 4 times 1, so half of 4 is 2. So it has area 2. And then the larger triangle down here, the purple one, if you count, you'll see that it has 8 units along the bottom and 3 units up. So its area is half of 8 times 3, that's half of 24, is 12. So its area is 12. Okay, so last step then is to get the area of our red triangle in the center, is to start with 32, which was the big blue rectangle, and subtract the others. So we've 8 and 2 is 10 and 12 is 22. So 32 take away 22 leaves us with 10 square units. So the answer is 10 square units. Okay, so let's look at a different way of doing that. Okay, alternatively, there is a formula to calculate the area of a triangle, and this is what it looks like. It's in the formula books. We'll have a look at that page in a moment. And it is half of. Now we have these straight bars here, and we've met them before with complex numbers and distance. Okay, it means the size of. Okay, so we're going to use them to take the absolute, not absolutely, the absolute value or the positive value of what's inside. So it's not possible to have a negative area. So if you get a negative area there by calculation, you just use the positive. Okay, so it's half of x1 y2 minus x2 y1. Okay, so now what do they refer to? We'll find out. They refer to the coordinates of 2 points. But notice that the coordinates for only 2 points are used, and we know that a triangle obviously has 3 points. So we have 2 points, x1, y1 and x2, y2. Okay, so why do we only need to use 2 points? Well, to use this formula, one of the points of the triangle must be 0, 0. Then we can leave that one out of our calculations and use the other two. Okay, so we must have a triangle that's set up like this, where one of the points is on 0, 0, and then the other 2 points take part in our calculation. Okay, so this is the page of your formula and tables book where you will find that formula. It's the coordinate geometry page, the line page, it's page 18, and you'll find area of a triangle OPQ. Now O refers to the origin, or 0, 0, and here's our formula here. Okay, now how do we use it? Find the area of the triangle with vertices 0, 0, minus 2, 1 and 3, 4. So we have 0, 0 as one of the corners of the triangle, so that's good, but we don't need to use it in the calculation. Okay, so I'll put a big bracket around that. The other two then we'll use as my points, x1, y1 and x2, y2. Okay, I'll go to my formula book. I'll transcribe the formula onto my answer page so that I can see it clearly and the examiner sees I've chosen the correct one. Okay, and then you just put the right number in the right place. Okay, so starting here with x1 is minus 2, so that's from the points above. y2 is 4, x2 is 3, and y1 is 1. Okay, we will now multiply out inside those straight lines. Okay, and we get minus 8 minus 3. So we now have half of the absolute value of minus 11. So here's where the absolute value comes in. There's no such thing as a negative area, so it cannot be minus 11. All right, or half of minus 11. We'll just take the positive value. So half of 11, which is 5.5 square units. Okay, so that's when we have one of the corners at 0, 0. Now, we move on to something called translations. The question that comes to mind from the previous slide is, what if none of the points of the triangle are at 0, 0? then you can't use the formula. So what we do instead is we choose one of the corners, choose a convenient point, and we move it to 0, 0. All right. As a result, we need to move all 3 points and the whole triangle, and it all gets moved by the same amount in the same direction. And this is called a translation. So best to see that on a picture. Okay, so let's take the triangle shown and let's move it so that one of the points is on 0, 0. Now you can't move it by itself. You have to move every single corner the same amount in the same direction. So let's look. This corner here, so I'm on the diagram on the left hand side. Let's take the lower corner, the lower point, and this gets moved to 0, 0. Okay, so you can see it gets shifted over there. Now you can't move it on its own or the whole shape will change. So what we need to do is we need to move the other 2 points the same distance in the same direction. Okay, so if you look there, if we take our first point here, let's call it point 1, it has moved 3 boxes to the right and 1 box down. And so that's what should happen to point number 2 as well. 3 boxes to the right and 1 box down. And point number 3, 3 boxes to the right and 1 box down. And what that means, if you join up the new points, is you should get an identical triangle of the same dimensions. Now, sorry, my drawing's not the best. Okay, so the triangle should not change shape, and it should not change size, and so it should not change area. Okay, so for each point, what has happened? We've gone right 3 boxes. That means that the x coordinate, we've added 3 to it, x plus 3, and it's dropped down by 1 box or 1 unit, so the y value has decreased by 1. Okay, and what we need to do is just repeat that for each point of the triangle, and that's called a translation. It's a sliding movement on a graph. Let's look at that. Okay, so there's our question again. All right, there's my triangle again, and we chose to move -3, 1 to 0, 0. Now you can choose to move any of the points. It doesn't, you'll get the same answer in the end. But we've chosen to move -3, 1 to 0, 0. Okay, that's what we chose to do. That is 3 units to the right, so x plus 3, and 1 unit down, so the y value is 1 less, y minus 1. So this must be repeated for the other 2 points. So that's what we did. So let's repeat that for the 1, 5. Okay, so we do x plus 3 means that 1 plus 3 makes 4, and y minus 1, that means that 5 minus 1 gives 4, and so we have a new point at 4, 4. All right, and the third point of the triangle, 5, 4, well, if we add 3 to the x value, x plus 3, that's what we get 8. 5 plus 3 is 8, and if we take 1 from the y value, we get 4 minus 1 is 3, so the new point there is 8, 3. And we now have 2 new points to use with the area formula. So they are what? The red points here are what we're going to use for the formula. Okay, so putting in the values just like before. Okay, we have half of 4 3's minus 8 4, so we have half of 12 minus 32. We get half of minus 20, so remember we always take the positive value of what's inside, which is plus 20, and half of 20 is 10 square units. Now you might recognize this answer. This is the same question as the very first one we did, where we took a different graphical approach with the big blue rectangle. Okay, so this is how you would do it using the formula. And we got the area of this triangle here to be 10 square units. Our new points were, after translation, were 0, 0, 8, 3 and 4, 4. And we got the same answer of 10 square units. Okay, you should try some exercises around that.